Hello everyone, today we'll be going to learn about the topic about motorcycle. So from today we are going to start a series on motorcycle, and there will be a particular playlist for motorcycle and its problems, solutions. Okay, so let's start with the definition of motorcycle. Well, motorcycle is a graphical tool that used in engineering to visualize stress states and analyze how stresses change on different planes with a material. Well, if I want to break down this, then it will be mm, in a more easier sense. It can be said that to understand the compressive or tensile stress and the shear stress applied on an object more precisely or in a graphical view, we use motorcycle. Motorcycle is a graphical tool that is used by the mechanical engineering students or mechanical engineers, and also by the civil engineers in designing considerations. Well, this is a method where we can predict, or we can actually determine the maximum shear stress, or the maximum principal stresses or minimum principal stresses that is actually happening, or that is actually uh, applying on a single body. So this is actually representation of motorcycle. This is just a simple representation. So in the x-axis we have the tensile or compressive stress, which is also known as the principal stresses, and in the y-axis we will be uh, applying or given by the shear stresses. Positive upper one is positive shear stress, and in the lower we will get negative shear stress. And as like in this side we will get the positive principal stresses, and in this side we will get the negative principal stresses. Well, so to apply or to use the motorcycle, we have to actually be very careful about the sign convention, because in this method sign convention is very much important. And in one, if you do blunder, or if you do miscalculation in the sign convention, then you will actually get very uh, deviated results, and your analysis will also get affected by it. Okay, so moving forward to it. So as we have just told about, let's just uh, imagine the thing. Okay, so just imagine that this is a plain body. Okay, this is a body. Let me actually, okay, so this is a body. One sec. Okay, so this is a body, and on this body, this is the, okay, so this is the x-axis, and this is the, okay, one sec, and this is the y-axis. Okay, so as per the x-axis we will actually have the principal stresses. Okay, but as we can see that if the force is outwards, it's like you are actually pulling the object from two sides, then the body will go under tensile. Okay, so body will go under tensile stress. Similarly, if we actually uh, change the direction of the force like this, then it will be compression stress, like compressive stress. Okay, so in throughout all our calculations we will take tensile stress as positive and the compressive stress as negative. Okay, so let me actually write this in a good way. Okay, so for tensile stress we will take the sign convention as positive, and for compressive stress we will be getting negative. Okay, so this is our sign convention, and let me actually uh, keep it under this like this. Okay, now moving forward, so we will get tensile stress as positive and compressive stress will be negative. Okay, so moving forward, the stresses can be applied in both the directions, as this direction principal stress, compressive stress, and it can be also be tensile stress. So in this plane we can also have, this is the tensile stress, and in the vice versa we can have a compressive stress, right? So in this plane we can also have the tensile stresses. Okay, so these are the situations that we will gonna face. Okay, okay, so here is another thing over here, that if the question says, okay, so if the question okay, so let's forget about the questions. If we can say, if we say that there is the shear stress. Okay, so shear stress, either it's clockwise, otherwise it's negative, anti-clockwise. Okay, so in this case we will actually take the clockwise as positive, and for the anti-clockwise we will get negative. Okay, okay, so this is said, and let me show in this figure that what is clockwise and what is anti-clockwise. So here clockwise means this will be clockwise. Okay, this will be clockwise. Okay, this is the clockwise direction. Okay, so now here is a confusion can arise, that um, as I have shown that this is clockwise, and clockwise is only based on the x-axis. Okay, so only based on the x-axis it will be clockwise or anti-clockwise. In the y-axis, or in the actually this surface, these two surfaces. Okay, so there will be some changes in these two surfaces. It's like as it is actually in this plane and in this plane, it will be shown, or it will be seen as the clockwise, and this will actually determine that it is a clockwise and anti-clockwise. So as this is actually moving this way, so it is clockwise. Okay, so for the clockwise I have to complete the uh, picture, or complete the figure. So how can I do it? So it will be like that, as it is going this word, so I have to make the diagram or make the object stable. So how can I make the object stable? So it will be anti-clockwise. Okay, so the other one will be anti-clockwise. So if a thing is, a object is prone to move this or clockwise, and if I actually apply the same amount of force on the anti-clockwise, so it will actually be null, and the object will be stabilized, or will be in equilibrium. So from that we can say that we have to complete the diagram like this. So for clockwise direction shear stress we get this. Okay, okay, so for anti-clockwise I will show you in future. Okay, okay, so now what we have to actually see, that there actually arises some points. Okay, So actually those points are those angles. Okay, so those angles are like these angles. Okay, these angles. But here is a catch over here, that these angles are always twice theta, twice theta. So this is a rule of Mohr cycle, and this is said by the Mohr, the scientist. Okay, so it will be 2 theta, and what will be the value of theta? Okay, so let me show you. So the value of theta will be the angle that is being made from, okay, so the angle, once again let me just change the color. Okay, so just imagine that this is a straight line. Okay, so if we actually make an angle with it, this will be theta. That is actually the angle between the principal stress that is been made. Okay, so the angle between the principal stress and the angle that is inclined, that we are actually wanting to determine the force against this plane. Okay, so in motorcycle we actually use it is like that. uh, Look, so this is an object. Okay, so if we incline the object by theta degree, just say theta degree, then how will the force will act, or what will be the maximum force, or what will be the minimum force, or what will be the maximum shear stress, or what will be the minimum shear stress? Okay, so this is actually the method where we have to just use the twice theta in when we are going to plot the motorcycle in the graph. We have to use 2 theta, and in the case of in the case of determining the for theta, we have to use 2 theta. Yeah, just like that. If the theta is 45 degree, then we have to use, or we have to draw here 90 degree. Okay, sorry for bad handwriting. Okay, so this is the basic. So far this was the basic of the motorcycle, and on the next video we'll be solving problems. Thank you for watching.